Everybody, in this video we are going to talk about globe, latitude and longitude, and definitely this is the chapter second from class 6 NCERT Geography. We are going to cover that. Okay, so what are the syllabus mapping and classification? So that's important of exam segment GS1, that you know about that subject physical geography again, and topic reference we have to do silent features of physical geography, in which we have mathematical geography like earth grid system, heat zones and time coordinate calculation. We are going to cover it. Okay, so first thing, डिटेल स्टडी नोट्स ऑन लाइक ग्लोब लैटिट्यूड एंड लॉन्गिट्यूड तीन चीज़ें यहाँ पे लाइक वी हैव थ्री थिंग्स लाइक ग्लोब लैटिट्यूड एंड लॉन्गिट्यूड्स. फर्स्ट ऑफ ऑल, the true shape of earth and the globe model. So geoid morphology. Okay, so the earth is not a perfect sphere. Definitely we know that earth is not a perfect sphere. It exhibits an oblate spheroidal. Okay, so it's oblate spheroidal shape, structurally characterized by being flattened at the north and south poles and bulging at the equator. That's called middle. Okay, due to centrifugal forces generated by its axial rotation. So just because of its axial rotation, there is a centrifugal force works, and that because of that it bulges the equator and flattens the north and south poles. The globe, a true three-dimensional 3D miniature model of earth. Okay, key features and mobility and rotation. Key features like countries, continents and oceans are represented in their accurate relative proportions and spatial dimensions. With mobility and rotation, like a globe can rotate freely along an axis from west to east, mimicking the exact rotational direction of the physical planet. The planetary axis, an imaginary line passing through the center of earth around which it rotates. Okay, passing through the center of earth around which it rotates. They have 2 points. Poles act as the two absolute terminal points where this imaginary that axial line precisely pierces means होता है क्रॉस करना, ट्रैवर्स करना. Pierces the planetary surface are the north poles and south poles. Note: real Earth features no physical needle or rod. Its acceleration is purely a function of momentum in space. Now we have to understand parallels of latitudes. Parallels of latitudes, we have equator. So there you can look at this equator. Okay, just wait a second. Yeah, just wait. Yeah, there we have equator. So equator, that's a 0 degree, an imaginary circular line drawn exactly halfway between north and south poles. So we have, there is north pole and there is south pole, and between half. Okay, so this is equator is like between half of it. So between the north and south pole, exactly half between the north and south pole, dividing the planet into two equal halves, northern hemisphere and southern hemisphere. So this portion is northern hemisphere and this portion is southern hemisphere. Yeah, it is absolute foundational baseline. So that's absolute foundation. This equator is absolute foundational baseline reference point for all latitudinal locations measurement. All latitudinal location measurement, because this row line is called latitude, and this vertical line, column line, okay, yeah, vertical line called longitude. Okay, this is called longitude, and this is called latitudes. Yeah, I got it. You got it, I guess. Definition of parallels: all concentric parallel circles running from equator up to both poles are termed as parallels of latitude. As so, this line is also parallels of latitude. This is also parallels. This is also parallels of. This is parallels of latitude. Okay? This is also parallels of latitude. I hope you understand that. Okay. Next one, we have measurement mechanism. What we have to measure and how we can measure it. So there's latitudes, and latitudes are measured in angular degrees. Okay. So we have to measure latitudes. Okay. Latitude. What the latitude measurement. Okay, latitudes are measured in angular degrees. So the total circumference of earth is 360. This is earth, and this is total circumference of earth is like just wait, this whole earth is about 360 degree. 360 degree. ठीक है, it is like 360 degree. Okay, So total circumference of Earth is 360 degree, and the angular distance from the equator to either pole is exactly 1/4 of that circle. And this is the equator, and this is the poles. So let's suppose if it is North Pole and South Pole. So okay, North Pole and South Pole. So there we have 90 degree. That's 1/4. So 90 degree is 1/4 of 360 degree. Okay. That is called the angular distance from the equator to either pole is exactly 1/4 of that 1/4 of that circle. That's called 1/4 of 360. That's 90 degree. You got it? Next. Therefore 90 degree north marks the exact north pole and 90 degree south marks the exact south pole. So if we have this is 90 degree north and this is 90 degree south. So this is south pole, this is north pole. Next, we have to understand directional designation. Every latitude coordinate must be appended with either the letter N for north or S for south relative to the equator to prevent coordinate duplication. So directional designation, like how we can designate directions. So every latitudinal coordinate must be appended with either letter N. हर एक coordinate को हम must भी हमें like letter N और S देना ही होता है, ठीक है, append करना होता है relative to the equator की relevance में to prevent coordinate duplication, जिससे coordinate duplicate ना हो पाए. केस कंपैरिजन लाइक एक बोथ चंद्रपुर महाराष्ट्र इंडिया में एंड वेले होरिजेंटल ब्राज़ील साउथ अमेरिका में सिट ऑन द 20 डिग्री पैरेलल, दोनों पैरेलल 20 डिग्री पे, बट वी डोंट नो लाइक पैरेलल 20 डिग्री नॉर्थ और 20 डिग्री साउथ, ठीक है. आवर चंद्रपुर इज लोकेटेड 20 डिग्री नॉर्थ नॉर्दर्न हेमिस्फीयर व्हाइल वेले होरिजेंटल लोकेटेड 20 डिग्री साउथ साउदर्न हेमिस्फीयर. दैट्स इट. A special property, the structural diameter and circumference of parallels of latitude. So we have parallels of latitudes and का जो structural diameter होता है and circumference होता है of that decreases progressively. So that is going to be decreases progressively as they move away from the equator towards the pole. As they move from the equator towards the pole, collapsing into absolute point 90 degree. Absolute point पे collapse होता है 90 degree पे, north and 90 degree south पे. Latitude by celestial observation. So how we can find the latitude by celestial observation? Like exact latitude of any given point in the northern hemisphere can be determined by measuring the angular altitude of the pole star, the north star, above the local horizon. Next we have important parallel and planetary heat zones. Okay, just wait a second. Important parallels and planetary heat zones. The differential angles, okay, the differential angles at which solar radiation intercepts. So एक differential angle होता है that at which solar radiation intercept करता है the curved surface of earth create the three distinct macroclimatic thermal zones. तीन distinct macroclimatic thermal zones यहाँ पे create होते हैं. First one is like torrid zone, that's it is called heat zones actually. So that's called like planetary heat zones. First one is torrid, then temperate, and then frigid zone. So we have three zones. Latitudinal boundaries we have to understand, solar insolation profile, and we have the thermal characteristic. First we are going to look at the latitudinal boundaries. Okay, latitudinal boundaries. So torrid zone between tropical Cancer, we understand tropical Cancer 23.5 degree north and tropical Capricorn 23.5 degree south. So first torrid zone found between latitudes, like latitudinal boundaries for torrid zone is like between tropic of Cancer and tropic of Capricorn. That's it. Temperate zone we have two positions, north and south. So we have two temperate zones, we have two frigid zones. So okay, so temperate zones in north between the tropic of Cancer and Arctic circle 66.5 degree. Okay, that's called Arctic or Antarctic circle. But if there's a north, then it is Arctic. If there's a south, then this is Antarctic. Okay, so in north we have tropic of Cancer and south we have tropic of Capricorn. Okay, so in north we have tropic of Cancer and Arctic circle, between that we have temperate zone, and in south between tropic of Capricorn and Antarctic circle we have temperate zone. In frigid zone we have 90 degree north pole and 90 degree south pole. Okay, so in frigid zone we have Arctic circle 16, in the north we have Arctic circle and a north pole, and in south we have Antarctic circle and south pole. That's it. You got the latitudinal boundaries. Now solar insolation profile. What has actually happened here? Okay, in torrid zone we have the midday sun. Midday sun passes directly overhead. So midday sun passes directly overhead at a 90 degree angle. Okay, so in torrid zone midday sun passes directly overhead at a 90 degree angle at least once a year on every single latitude within this zone. Okay, that's why it faces too much heat. Okay, In temperate zone, the midday sun never shines directly overhead. It never shines directly overhead, but the angle of sun's rays decreases continuously towards the pole. So, spreading energy over a larger surface area. So, in that way, we'll find what happened in thermal characteristic. Okay. Third one, like we are talking about solar insolation profile, how solar insolation works in these regions. Okay, in frigid zone, sun never rises significantly above the local horizon line. Rays hit an extreme, highly scattered, slanting angle, offering minimal thermal energy. Okay, now we have to understand thermal characteristics. So in torrid zone, just because of like midday sun passes directly over at 90-degree angle, at least once a year on every single latitude within the zone, so that's why it receives the maximum concentration of solar radiation, like maximum concentration solar radiation, so hottest zone of Earth. Second, temperature, midday sun never shines directly overhead. The angle of sunset decreases continuously at the poles and spreading energy over a larger surface area, so characterized by moderate, balanced seasonal temperatures. Frigid zones, frigid is actually subject to extreme perpetual cold because region is that sun never rises significantly above the local horizon line. Rays hit an extreme, highly scattered, slanting angle, offering minimal thermal energy. That's it. Next, we have meridians of longitude. Meridians of longitude. Okay, just wait. Now next we have meridians of longitude. Actually, definition of it. Okay, so to fix an exact position on a sphere, like latitude alone is insufficient because it just found north and south. Okay, what about east or west? Okay, for instance, both the Tonga Island, Pacific Ocean, and Mauritius Island, Indian Ocean, is precisely on 20 degrees south. So दोनों 20 degree south पे ही हैं, पैरेलल भी हैं. ठीक है, to locate them we use a vertical reference lines running directly from north pole to south pole. ठीक है, termed as meridians of longitude. Geometric properties, unlike latitudinal loops. Okay, unlike latitudinal loops, all meridians of longitude form equal length semicircles, unlike latitudinal loops. So loops, like latitudes are the loops. Okay, unlike latitudinal loops, all meridians of longitude form equal length semicircles that terminate at the poles. Okay, geometric properties of longitudes, unlike latitudinal loops, all meridians of longitude form equal length semicircles that terminate at the poles, and the linear distances between individual meridians decreases steadily polewards, converging to exactly 0 at the poles where all lines intersect. Subdivision, longitude degrees are broken down precisely for micro targeting. 1 degree for 60 minutes and 1 minute is equal to 60 seconds. The prime meridian, that's 0 degree, because all meridians are structurally identical in length. Nations globally agreed to establish a uniform baseline starting line 0. This line passes directly through the British Royal Observatory at Greenwich, London. Hemispheric split, the prime meridian is 0 degree and direct structural continuation, that's 180 degree meridian, divide the earth cleanly into two halves, the eastern hemisphere east and western hemisphere west. The 180 degree convergence, the 180 degree east and 180 degree west meridian do not point in opposite directions. They meet to form the exact same physical line on the opposite faces of the planet. The geographic grid, the intersecting network of parallels of latitudes and meridians of longitude. Any absolute spot on the earth can be pinpointed where these lines intersect. Example, Dhubri in Assam is located exactly where 26 degree north latitude and intersects 90 degree east longitude. Next we have longitude and time mechanics. The diurnal rotation, that's called Earth Day. Okay, the diurnal rotation of the Earth provides natural, highly precise cosmic framework for time reckoning. Local solar noon occurs when the sun reaches its highest point in the sky, causing shadows to contract to their shortest daily length. Okay, the mathematical engine of the universal time. The planet undergoes a complex axial rotation 360 degree. In approximately 24 hours, this translates to a fixed operational rate of hourly rate 360 degree 24, that's 15 degree per hour, and minute rate 16 minutes is equal to 15 degree, that's like 4 minutes per 1 degree of longitude. Next we have to understand directional time calibration, west to east rule calibration. Directional time calibration, west to east rule, because earth rotates from west to east. Okay, Time progresses chronologically from east to west. Directional time calibration, which is called west to east rule, because Earth rotates from west to east, time progresses chronologically from east to west. Okay, places situated east of Greenwich are temporarily ahead of GMT, and places west of Greenwich are temporarily behind GMT. Okay, worked calculation examples. If the current local time at the prime meridian 0 degree Greenwich is exactly 12 noon, okay, so at 15 degree east, time changes 15 degree into 4 minutes, that's 60 minutes. It's 1 hour ahead, like 1 p.m. And at 15 degree west, it would be 1 hour behind 11 a.m. At the 180 degree meridian, opposite side of the planet, 180 degree into 4, that's 720 minutes, is equal to 12 hours. So 12 hours midnight, okay, rather than noon. Next one, we have standard time and time zones. Standard time and time zones. Why countries need standard time? Why need standard time? As a planet rotates, every meridians undergoes solar noon at a slightly different time. So if a country calculates the time purely by local solar noon, time will vary across its territory. For example, India faces an internal local solar system. India faces an internal local solar time variance of approximately 1 hour and 45 minutes between Dwarka, westernmost Gujarat, and Dibrugarh, easternmost Assam. Okay, that's called like variance. Will find variance approximately 1 hour and 45 minutes between Dwarka and Dibrugarh. This variance would disrupt transportation networks, banking operation, and administrative systems. So Indian Standard Time. That's why we need Standard Time. Now we will talk about Indian Standard Time. To maintain national synchronization, India designated a central meridian to govern its official time. Standard Meridian of India, 82.5 degree, 82 to 30 minute east, passes point geographically bisects India, passing directly through Mirzapur near Prayagraj, UP. IST Indian Standard Time offset calculation 82.5 degree is 4 minutes is equal to 350 minutes means 5 hours and 30 minutes. Okay, because 300 minutes would be 5 into 60 minutes, that's like 5 hours. Okay, status. India is located entirely east of prime meridian, therefore IST is strictly 5 or 30 minutes ahead of GMT, that's UTC. GMT or UTC, like GMT plus 5:30. Particle Practical case, if a cricket match begins 2 p.m. in London GMT, the live broadcast begin in India 7:30 p.m. IST, 2 p.m. plus 5.5 hours, that's like 7:30 p.m. Indian time. Next one, global time zone system. Standard framework. Earth is divided into 24 distinct standard time zones, each spanning exactly 1 hour rotational time and covering 15 degree of longitudinal wealth. Whereas a multiple standard time, several sovereign territories with vast east-west longitude reaches cannot function single under a single standard time zone. Russia spans an immense longitudinal expanse, officially observes 11 distinct standard time zones ranging continuously from UTC plus 2 to UTC plus 12 without daylight saving time. Russia spans an immense longitudinal expanse and officially observe 11 distinct standard time zones ranging continuously from UTC plus 2 to UTC plus 12 without daylight saving time. United States and Canada similarly manage their expensive geographies by utilizing multiple standard time zones. So this chapter is also going to be end, and I hope you understand the chapter and hope you like it.